Emirates has completed the world's first A380 demonstration flight powered entirely by 100% sustainable aviation fuel, used on one of the aircraft's 4 engines. The flight is one of several efforts to demonstrate that neat SAF is a viable fuel for aviation. According to some estimates, 100% SAF can reduce flight carbon emissions by up to 85% compared to traditional jet fuel, but it has yet to gain regulatory approval. Currently, only blended SAF flights, where a portion of the fuel comes from an SAF source and the rest uses traditional fossil-based jet fuel, are technically approved and authorized by regulators. The current cap on SAF to jet fuel blend is 50%. However beneficial, the quest to approve 100% SAF use in aviation runs into a second major challenge: a need to increase supply. Blended or neat, airlines need more SAF. SAF comes from waste processing, leftover cooking oils and plant pulp, sustainable feedstocks, and even from removing carbon dioxide from the air and converting it to liquid fuel through an electric process. However, the technology to make sustainable SAF at scale is still in development. Aviation demand will be substantial as airlines work toward net zero emissions. The International Aviation Transport Association estimates that airlines will need 120 billion gallons of SAF annually to meet their environmental targets. The estimated production of SAF in 2022 was 75 million gallons, while SAF currently accounts for a minor portion, 0.5%, of aviation fuel use. Airlines aim to increase their share to 10% by 2030 and continue growing their share of SAF as supply increases. The net zero emissions target airlines set for 2050 relies on 65% SAF use. Emirates A380 100% SAF demonstrator flight. The SAF, which powered the Emirates flight, comprised a blend of hydroprocessed esters and fatty acids, synthetic paraffinic kerosene from Nest, and hydrodeoxygenated synthetic aromatic kerosene from Virent. INOC secured the neat SAF and blended it with sustainable aviation kerosene at its facility at Dubai International Airport. The 100% SAF powered one-engine Alliance GP7200 engine on the aircraft. The other 3 engines on the aircraft used conventional jet fuel. The PW980 auxiliary power unit from Pratt & Whitney Canada also used 100% SAF. The demonstration flight coincides with the 3rd ICAO Conference on Aviation and Alternative Fuels, hosted in Dubai. Sustainable aviation fuel plays a crucial role in reducing the emissions of air travel, but to fully leverage its decarbonization potential, we need to enable 100% SAF use, said Jonathan Wood, Vice President of Commercial Management and Business Development of the Renewable Aviation Business at Nest. Virent President and General Counsel Dave Kettner said, "With Virent's plant-based fuels technology, this test flight showed that 100% renewable fuel can meet current specifications and work flawlessly in today's commercial airline engines. It's critical that a consortium of companies, like this group, come together to bring sustainable aviation fuel into more widespread use. We are dedicated to ensuring all of Pratt & Whitney's engines and APUs are compatible with current and future SAF specifications, up to 100%, said Pratt & Whitney Chief Sustainability Officer Graham Webb. Aziz Kolilat, Vice President of Global Sales and Marketing for the Middle East, Eastern Europe, and Turkey at GE Aerospace, echoed the sentiment, saying, "All GE Aerospace and Engine Alliance engines can operate on approved SAF blends today, and through extensive research and testing, GE Aerospace is helping lead the approval and adoption of 100% SAF in the aviation industry." Airbus, which developed the A380, is working with partners to make their aircraft 100% SAF capable by 2030. Julie Kitcher, Airbus Executive Vice President of Communications and Corporate Affairs, commented, "Seeing Emirates flying an A380, the world's largest airliner, powered by an engine running on 100% sustainable aviation fuels is a symbolic moment. These fuels are the most effective way to address CO2 emissions in the aviation industry today." This flight builds on Emirates' ongoing efforts to use SAF, including previous demonstrations and partnerships to increase SAF supply and contribute to the UAE's Sustainable Aviation Fuel roadmap. Emirates completed the region's first 100% SAF-powered demonstration flight on a GE90-powered Boeing BA plus 0.8% 777-300ER in January of this year. That was through a partnership with GE Aerospace, Boeing, Honeywell, Nest, and Virent. In this test, the 100% SAF powered one of two GE90 engines on the aircraft and a Honeywell APU. This marks another significant step in validating the use of SAF in one of the engines of the A380, a wide-body aircraft with 4 engines, said Adel Al-Reda, Chief Operating Officer. Emirates, of the A380 demonstrator flight. The growing global demand for lower-emission jet fuel alternatives is there, and the work of producers and suppliers to commercialize SAF and make it available will be critical in the coming years to help Emirates and the wider industry advance our path to lower carbon emissions. Virgin Atlantic gets UK permit for 100% SAF transatlantic flight. Virgin Atlantic has received permission from the UK Civil Aviation Authority to conduct a transatlantic flight from London to New York using 100% SAF. This flight, scheduled for November 28, is set to be a world-first event, demonstrating a significant step in the airline industry's efforts to reduce carbon emissions. The airline aims to use 10% SAF by 2030. Virgin Atlantic has called for government support to expand the UK's SAF production due to limited quantities available and higher costs compared to conventional jet fuel. Powering business jets with 100% SAF. Gulfstream conducted the first transatlantic flight using 100% Sustainable Aviation Fuel, SAF, with their G600 aircraft. The flight took off from Savannah, Georgia, this weekend and landed at Farnborough Airport near London, after flying for nearly 7 hours. Gulfstream used unblended SAF in both engines, provided by World Energy and delivered by World Fuel Services ENT-0.9%. The data from this flight will help assess aircraft compatibility with future renewable fuels. Embraer has also successfully tested its Phenom 300 and Praetor 600 aircraft using 100% SAF in October. The tests, conducted at Embraer's facility in Melbourne, Florida, were in collaboration with engine makers Pratt & Whitney and Honeywell Engines. Embraer's aircraft can currently use up to a 50% SAF blend. Ramping up U.S. SAF production. Airbus partnered with DG Fuels, LLC in the U. Ramping up U.S. SAF production. Airbus partnered with DG Fuels, LLC in the U.S. to ramp up SAF supply. DGF converts cellulosic waste products, like wood waste from the logging industry, into sustainable fuel. The company uses renewable energy sources, like wind and solar power, to convert the waste into SAF. This partnership aligns with the U.S. government's SAF Grand Challenge, which aims to lower costs, increase sustainability, and promote domestic SAF production. The initial target is to produce 3 billion gallons of domestic SAF annually by 2030. The long-term goal is to cover 100% of projected aviation fuel demand by 2050, which would be 35 billion gallons. Europe mandates increasing SAF blend for aviation. The new RefuelEU aviation regulation, confirmed in October, requires aviation fuel suppliers to blend increasing amounts of sustainable aviation fuels, SAF, with kerosene, starting with a 2% minimum blend in 2025 and rising to 70% by 2050. This requirement pressures airlines to adopt SAF blends quickly and urges fuel producers to accelerate the SAF production process. Ireland could take the lead on SAF. A feasibility study backed by aircraft lessors Avolon, Boeing, and Oryx Aviation suggests that Ireland could also become a leader in SAF production. The study finds that Ireland would need around 10 SAF plants with a production capacity of 80 kilotons each to meet domestic demand and open up export opportunities. One advantage the study identifies is the potential production of SAF through power-to-liquid technology as the most promising avenue for Ireland. Because it does not rely on waste or feedstocks, PTL SAF is the most sustainable SAF option to scale for long-term supply. Ireland's program would combine green hydrogen, produced through renewable energy-powered electrolysis, with biogenic CO2, enabling the synthesis of SAF. Additionally, the study finds that SAF from bio-based intermediates, like renewable natural gas, could fulfill the advanced biofuels portion of the RefuelEU mandate rapidly. However, developing a domestic SAF industry at scale in Ireland requires enough renewable power for hydrogen production. The study counts on the Irish government's initiatives to increase offshore wind power generation by 2030. UK backs British Airways project Speedbird SAF partners. The UK also supports sustainable fuels for aviation, from SAF production to hydrogen-powered flights. Project Speedbird, a partnership between Nova Pangea Technologies, NPT, LanzaJet, and British Airways, BA, has received £9 million in funding from the UK government's Advanced Fuels Fund, AFF, competition. The project would produce 102 million litres of SAF annually when it reaches total capacity by 2028. The SAF will come from a combination of NPT's technology, which converts agricultural waste and wood residue feedstocks into second-generation biofuels such as ethanol, and LanzaJet's technology for converting ethanol into SAF. The NPT ethanol will be initially processed into SAF using LanzaJet's alcohol-to-jet plant in Georgia. Through Project Speedbird, a larger ATJ facility will be built in the UK by 2027. British Airways has committed to buying 100% of SAF production from this program.